Hello and welcome to the session. In today's session, we'll be discussing about the relational model. The relational model is one of the most important model as far as database management system is concerned. Whenever we talk about models, what exactly we are discussing? When we talk about models, we are basically discussing two or three basic things. The very first thing which we would like to discuss when we talk about model is the organization of data or the structure of data. That is how the data would be organized in that particular model. Then comes different kinds of constraints which can be put onto the data of that particular model. And then finally the operations which can be associated with a particular model. Well, the basic structure of database management system, right, is relational. It's a two-dimensional table, okay, also called a relation. So whenever we talk about relation, it is basically we are talking about a two-dimensional table. And data organized as table simplifies the enforcement of integrity constraints and database operations. This we will see with the help of an example, but the most important thing over here is to understand that when we use relational model, we can very simply apply integrity constraints and we can perform several operations on data. Let's try to take an example of relation. Well, if you see, there is a typical relation being shown, and the name of this particular relation, okay, is person. And what you see, if you see over here, the first row of this particular relation, it is representing the attributes of the relation, right? So person ID happens to be the first attribute, name happens to be the next, age and address are all the attributes. And on this particular side, the actual data you can see from second row onwards, the actual data. So what you can see, person ID 1, there is a name associated with it, the age is associated with, and an address is associated. Similarly for 2 and 3. So these are the tuples. These are called the tuples of a relation, right? Why do we use relational data model, and what are the advantages of using relational model? Well, the very first advantage of using relational model happens to be that it is very easy to use. And why it is easy to use? Because it contains the tabular structure. Okay, now you can, for example, look into the slide. Please, yeah, in the slide, what you can observe, okay, manipulation. So what we can do, we can add new data easily. Another row can be added, okay, or anything can, whatever information you want to delete, you can easily delete that information. And data manipulation. Suppose you want, you found out that the age of this particular person is incorrect. So you can always change this particular age to, suppose it is 32, then you can always make it 32. All right. Then other basic operations. So these are two basic operations which we have stated: insertion of a record, deletion of a record, and changing any value within the table. So relational model basically provides you a lot of flexibility as far as data is concerned. So you can now, one more thing which you can do over here, we have added another column in addition to what was existing earlier, right? So this was with the ease of use. Now the next thing now you can do is the flexibility. I have just added a column here, and that column addition was one of the very simple way. We have just added another column. So that is the beauty of relational model, that it allows you, it is easy to use, it is flexible. Is there any more advantages? Yes, accuracy. Accuracy is in relational model because of the relational algebraic operations which are possible, right? So you can manipulate data values, okay, and you can put a lot of integrity constraint over these values. For example, on age, we can always specify that the age should not be more than 60 years. So now that kind of a constraint puts a restriction on the age, and by mistake you won't be able to put age something like 70 in that particular case. So like that, a lot many accuracy related constraints can be specified as far as relations are concerned. So this is something which is very useful kind of information about database, the relational database, and that is why they are very, very popular, because of the simplicity, ease of use, then integrity constraint, and the set of operations which you can perform very easily on the data. Okay, but what are the basic terms which we utilize as far as the relational databases are concerned? Well, the terms which we use are rows, like these are the rows, as we do call them in tables. They are called tuples in relational database. So these are the tuples, or the information. Tuple contains information about one particular person. All right. And it is basically a record of a particular person. So that's why the three names, row, record, or tuple, right? Then attributes basically are the columns, right? So this is attribute name. Person ID is the attribute name over here, and the value happens to be 1, 2, and 3 for 3 different persons, right? Similarly, name is the name of the attribute referring to here, and 3 different names are appearing over here. So is the age, like that. So these are the attributes. So there are 5 attributes in this particular relation whose name is person. So first thing is the name of the relation. So there are 5 attributes over here. So that is why it is called 5 tuple, right? A tuple is 5 tuple. Okay. Why? Because 5 attributes. So each tuple or each record, let's call record or tuple, contains 5 attributes. That is why it is called 5 tuple. So that is how you basically recognize the data as the databases or a particular table is concerned. But there are many important terms which we associate with a database system. And the very first important term here happens to be the domain. Now, domain is one of the most important thing to understand, because it talks about the overall paraphernalia under which a particular value can be assigned, right? So a domain is a set of permissible values that can be accepted by specific attribute. The example of over here is that domains of person ID, say, can be from 1 to 100, right? Because we are assuming that there are only 100 persons in this particular situation. That's why we say that it is from 1 to 100 only. The domain of age may be from 0 to 150, right? If it is just about all person, because some person are above 100, 110, 115. So for them also, this particular, you should be able to record the information. So under that situation, we might like to put the domain of age to be in this particular range. All right. So this is how the domain. So domain basically are specifying the values that can be associated with a particular attribute. So a column can contain only those attribute values. So automatically it puts a restriction on the values, and once again that is a sort of integrity advantage. Well, relational model, there are certain key characteristics. That is, each table is a relation. That's what we call. A relation is defined using 2 basic aspects. One is called the schema, and another is called an instance. Now this instance term is very, very important for you. So remember this particular term. The schema basically defines, which is denoted as capital R. Okay, it is denoted with capital R. It specifies the name of the relation, the list of attributes of the relation, and the domain of each attribute. So a relation, if is denoted as R, A1, A2 till AN, so R is the name of the relation, okay, and A1 happens to be the attribute and its domain specification, right? So the relation N, R, has how many attributes? There are N attributes named A1 till AN, and that is also called the degree, right? So degree of a relation. So this relation whose name is R, okay, happens to have a degree N. All right. So this is how a relation is recognized. This is the simple example for this particular situation. Once again, we are utilizing the same example. Okay, so if I want to define the schema of this above relation, how I am going to represent it? What was the name of this relation? Person. So person, okay, person ID is of the type integer. So that is what has been specified. Then name is of the type character. Actually, you can specify the length of characters also. Okay, length in the sense that number of characters that can be specified here, let's say 25 or 30, that also you can give. That makes the maximum length, and that also defines the domain in that particular way. Age happens to be once again integer. Okay, over here we can put another constraint that age has to be between 0 to 150. This domain specification is concerned, and the address that is character. Okay, so this is typically a schema of this particular relation. All right, and what is the degree of this relation? The degree is 4 because there were 4 attributes in this particular relation. Now, what do you call, so schema is fine, so schema is just specifying the schemata of a particular relation. But you want to put values in the table, right? Then it will be very useful, okay? So after you have defined the schema of a relation, then you would like to define the instance. An instance is basically a particular moment of time or point of time, and the number of records or the tuples that particular relation would have. Okay, so a relation instance denoted as small r. If the capital R was the relation, okay, the relational schema, and small r is the instance, and it is collection of tuples for a given relational schema at a specific point of time. A relational state of R of relation schema denoted by R, capital R, A1 in AN are denoted by small r within the parenthesis R. So this is an instance, that is small r is an instance of a relation whose schema is capital R, is a set of n tuples, okay, because there are n tuples given over here. So these n tuples, okay, now there are, this is a set of n tuple. Each tuple has n attributes. That's what it means over here. And over here what it means is number of tuples or number of records. So there are m number of records which have been put. Okay, has total number of m tuples or m records in this schema, where each tuple is an ordered list of n values, which is basically representing V1 till Vn, where V1 corresponds to A1, V2 corresponds to A2, and Vn corresponds to An likewise. Okay, and there can be certain null values also. So a particular instance of a relation can contain certain null values, and null values are also allowed in a relation, but only at specific locations. Suppose there is a key attribute, it is not allowed. So let's talk about those a little bit later. So let's talk about relational instance example. So it's a slightly different example, where we have student relation. Roll number is of the type string, name is of the type string, login is also of the type string, and age is in integer. So this particular relation, this is a typical the student relation, and the instance basically consists of two tuples, and each tuple is actually consisting of the order of the tuple is n. Okay, the 4 in this particular case, and just two tuples are being shown in this particular case. Now note that even roll number we said that is of the type string, and we are using 3, 4, 6, 7. So string can also contain the number that is allowed, right? So that is how you are seeing the numbers as far as strings are concerned. And digits, these are numeric digits in that particular case, and they will be treated as strings only. Okay, they will not be treated as integer, which the age is going to be treated. So age is going to be treated as integer as its domain is integer. All right, so this 21 is an integral number, whereas this 3, 4, 6, 7 is going to be treated as a string only, although they are numeric digits. So this is a typical case or typical example of relational instance. Well, another sample which is there, okay, this I have already explained. So tuple 1 consists of these values for the relation instance, and tuple 2 consists of the second value. Okay, this is T2. Okay, you can refer to in this particular diagram, and there are two tuples only, so m, the value of m is 2, and each tuple contains 4 attributes. So this is what is explained further. Another example is once again person. Okay, so over here how many tuples are there? M equals to 3, and each tuple has 4 values. So you can see that in this particular case you will be having 4, that is the order of this particular relation is 4, and that you can see from there. Let's now talk about some basic points about relational model. Okay, the very first point is, if a relation has proper integrity constraint, then each tuple of the relation would be a valid value. For example, in this particular case, if we put proper integrity constraint, then age is not going to exceed a particular limit. All right, so this is one particular situation. The null values can be assigned to only some of the attributes where the values are unknown or missing. Now this is a very interesting case. For example, if we do not know the value of a person whose person ID is 1, okay, suppose we do not know that value, okay, then instead of 35 we would be writing blank, okay, just null. Now null you don't write when it is integer value, you just leave it nothing. Okay, you don't put anything over there, and it is treated as null value in this particular situation. Okay, you don't even put a blank over there, okay, because blank is also a character, okay, and it is going to cause some problems for you. So you have to be very cautious when you are dealing with null values. Null means you are not putting any value over there, okay, and it is automatically treated as null value. Thereafter, ordering of tuple. Okay, next point is ordering of tuples is not defined as part of a relational definition. What does it mean? Now the ordering, like this person ID whose ID is 1, 2, 3, this order can be anyway. Okay, order does not matter. Okay, suppose I want to order the tuples in the order of age, right? Then this person ID 2 will be appearing first, followed by person ID 1, followed by person ID 3, right? So this is allowed in relation. Okay, so in relation, ordering of tuple it does not matter. All right, that's what ordering of tuple is not defined as part of a relational definition. For the purpose of display, you may get those tuples displayed in sorted order. Just like I gave you an example that we can display the information or the tuples in the order of age. Or you can also display these tuples in the order of name. Luckily for us, they are already in the order of name in that particular sense. All right. So, and in order of person ID, so they are also in the order of person ID. But you can always display these tuples in any different sorted order of your choice. Then records may be organized later according to some attribute value in the storage system for performance reason. Now you must remember one thing in this particular situation, that a relational database management system is a secondary storage structure. Why? Because the size of the database is normally such that it cannot fit into the main memory entirely. And most of the operations as far as database systems are concerned are performed in the secondary storage. Since most of these operations are performed in the secondary storage, therefore, that secondary storage is to be organized in a particular way. Okay? And most of the time, this organization is in the order of primary key of that particular relation. The relation model does not allow duplicate tuples. Now, this is one of the most important things for you to understand. You cannot enter record of same person again. And that is a very important criteria. Why? Because no duplicates are allowed as far as relations are concerned. Now, remember a particular thing when you create table in different software like MS Word or so, you can enter as many records of a person without even any problem, right? So there is a possibility of duplicacy. But relational database management systems make sure that no duplicates are allowed. And that is a very important thing as far as databases are concerned. Now, let us now finally talk about some of the concept as far as related to the key of the relation, which basically recognizes how do you distinguish between two tuples in a relational database management system. Okay, so the very first term which is defined, okay, all tuples in a relation are unique. So that is the property with which we are dealing with. All records are unique. How can you uniquely identify a tuple in a relation? So you should be able to uniquely identify that particular record. Right? So if you want to uniquely identify that record, how you are going to do that? Well, there are three concepts associated over here. One is called the super key. The second one is called the candidate key. And the third one is called the primary key. So let us look into the super key first. A super key is an attribute or set of attributes used to identify the record uniquely in a relation. Right. So now person ID, name, age, all three attributes together, okay, they are quite distinctly identifying that they are identifying the address of that particular person. So they are very unique in that particular way. Right. Unique not in a one particular instance, but all the instances, possible instances, they should be unique. So person ID plus name plus age can form a super key of this particular relation without any problem. Okay. Similarly, this person ID, you can see this particular thing. Similarly, person ID as well as name once again can form the unique. In fact, person ID has been designed specifically for the purpose that it is unique. Right. So if that is the case, that we are trying to recognize person ID, a particular person as a unique person ID, right? So only person ID or only name, suppose we just assumes that name are also unique. So only person ID or only name of that particular person can identify that particular record. Right? The information about that particular person. Now that minimal, a candidate key, that particular thing is called a candidate key. A candidate key is the minimal super key, which means that a candidate key does not contain any extraneous attributes. A relation may have several candidate keys. A candidate key may contain one or many attributes of a relation. It can be composite also. So in this particular relation, what we see, person IDs are unique. So are the names, assuming that the names are unique. But age may not be unique in all the instances, right? And so is the address may not be unique in all the instances. So we have two candidate keys, person ID as well as name in this particular situation. So if we have that particular candidate keys, okay, now the properties are, in any instance of a relation, the value of candidate key attribute should be unique. That's what we have said. Candidate key should have minimal set of attributes. You cannot put a null value in the attribute of a candidate key. Okay, this is called entity integrity rule. A candidate key is unique and not null. It has already been stated. And the value of candidate key must be stable. Okay, that is, it should not change frequently, or its value change should not be outside the control of the system. So it should be a stable candidate key. Finally, the primary key. A relation can have more than one candidate keys, and one of them can be chosen as primary key. So person ID actually is the primary, we can choose as a primary key, because we have designed this particular key to be of that kind. We are giving different person ID to each and every person, right? So this can be chosen as primary key in this particular situation. Okay, so in summary, if we can just summarize what we have covered so far, we have introduced the basic terminology and features of relational model. The second point is data in relational model is stored as tables, which are also called relations. Each relation has a relational schema and relational instance. Relational schema defines the schemata, and relational instance defines the values associated with it. Each relation instance contains an tuple, and in addition we have defined various terms which are associated with relational database systems like attributes, superkey, candidate key and the primary key. With this we end this particular session. Thanks for being with us.